a separate range to explore on infection probability. So we'll set that to a range. And this one's going to have 11 possible values going from 0, 0 to 10. What am I doing there? Make it 0 to 1, step 0.1. I was out to lunch. 0 to 1 and a step of 0.1. So here this has 11 different values, and what we're going to do is look at the intersection of those two. So if we were to run this out with that being specified, how many runs do you think we're going to have? Okay. Anyone want to hazard another guess? Let's see what it turns out to be. What's the jackpot? Anyone want to guess? 55. Where'd that 55 come from? Yeah, it's 5 times 11, and that's because we're varying both at the same time. This one, and we're examining again all possible combinations of them. So conceptually, we have sort of a full factorial type of situation where we have one of these things varying along 5, 10, 15, 20, 25, and the other, so this is the duration, and the other, the probability going from 0 to 0.1, 0.2, and essentially what we're doing is we're filling in this table. So we're filling in, we're doing every calculation according to every box of this table. Now what we're actually doing is summarizing it in terms of output, right? This is the result we get, and it's kind of washed out. Can you see it better on your screens? There's actually a fair bit of structure up here that I can see on my screen of runs that went up here. But what's this? What's with this line at the bottom? What do you think that represents? Sorry? Yeah, those are points. And so what this is actually saying is that if you examine all combinations of these, most of the realization, I've got to be careful. Most of the probability weight. If you think of this, remember I argued that every sort of little increment of this, I think maybe it's of size, what do we have, 40 of these? So every, more than 40. I can't remember how many we had along this axis of the bins. But every bin along here, if we sliced it for a given interval of time, it's basically a histogram. Basically a histogram coming up out of this. So these boxes are coded to how high the count is within that histogram at this time, what number are here and what number are further on here. What we see is that it's kind of a long-tailed histogram. The vast amount of the weight is here, and then it sort of declines precipitously, but then you have this kind of long tail that goes way up here, and so on. Now, again, what this is obscuring, what this is not letting us see, is that for a particular trajectory, is it the fact that these are simply taking longer time to come out and then they go up, or is it indeed that most just never go up at all and then some go up? There's a difference there. I mean, in other words, it could be that some remain here for a long time and then peak later, versus just a large number that stay totally flat and then only some that come up. I think it's more the latter. I think you have this very sort of divergent situations. But suffice it to say that these histograms have the vast majority of the weight here and then a long tail. And if we want to explore this further, we could. I mean, I can see on my screen that there are actually, you can kind of see this number is small enough, it's 500 here, or sorry, 55 here, that you can actually see individual trajectories. Can you see those on your screen? Sort of things etched by individual trajectories. So there are some that sort of play out here, some that still go up here, some that play out here. There's actually a larger number that this is a little bit thicker. So there's, of those that take off, they're taking off up here. So this is a multi-way sensitivity analysis, and perhaps surprisingly suggests that once you look at combinations of these, the vast majority are kind of weighted down here. So, you know, if you were to try to summarize, if you have active outbreaks that you're trying to reproduce here, you know, whole regions of the space would probably have very little chance of an outbreak. So, in any case, that's simple examination of multi-way sensitivity analysis here. Right. Okay, so we're going to now be examining the issue of imposing probability distributions on parameters. So what we've been doing is examining systematic variability